Laser cladding technologies have opened a wide spectrum of possibilities for enhancing the properties of metallic components by adding ad hoc developed advanced coatings on their surface. Nevertheless, the direct application of laser is not always possible without risking the integrity of the parts.
Cast iron does not respond well to the application of laser on its surface. The direct heat transfer can provoke embrittlement, high residual stresses, cracking, carbide and martensite formation, porosity, that will negatively affect the mechanical properties of the castings.
For sure, this is quite a limitation for manufacturing castings that are more resistant to corrosion or wear with a greater flexibility and at a lower cost than the currently available methods, which usually include further processes that also increase the cost and the lead time of the parts. To overcome this limitation, AZTERLAN has developed a new method targeted at conditioning the surface of the iron castings, so they are suitable for laser cladding. For this purpose too, ad hoc developed metallic powders have been the clue for the team.
We have created a reactive paint based on ad hoc designed and manufactured metallic powders, specifically, a self-cast and self-atomized nickel-titanium alloy with an ultra-low carbon content. The paint is used to coat selected sand mold surfaces and reacts with the molten cast iron during casting and solidification. This reactive paint behaves as a primer that gets the surface of the part ready for the next step.
Therefore, the reactive paint is not the only innovation the team has come through. And the method of application of the paint, by adding it to the sand mold cavity, is also a significant achievement, especially as they are looking for process efficiency. After applying the reactive paint in the selected areas of the mold cavity and the cores, and once the reactive paint is dry, the casting process can be performed as usual, by pouring the molten metal and letting parts cool down as in a usual foundry process. After demolding, the as-cast parts are ready to be coated by means of LMD. This innovation offers a hint of how metallic powders open a great range of development opportunities in various fields regarding the manufacturing of multi-material components and building single material parts through the hybridization of manufacturing technologies. This is currently a strong bet and a significant field of action for AZTERLAN in their path to develop more performant and more competitive components.